Practice problem, polar to rectangular, and the coordinate we're going to change will be in the first quadrant. So we'll make this one pi over 6. Actually, we need to write the radius first, and we'll make that one 7, and then pi over 6. 7 and pi over 6. We'll zoom that down a little bit so it can show up on the video. Okay, now we have to go to pi over 6, which is going to represent what degree marking? 30 degrees, yeah, so we're looking at this one here, and we need to go out 7. So it's going to be 1, 2, 3, 4, 5, 6, 7. Right there is the dot. Okay, now we need to make a right triangle. Now I can zoom this in. The right triangle goes here, here, and then here. Right triangle. We already know the hypotenuse of that. It's going to be 7. And we already know the measurement for theta in here, that is 30 degrees. We will label what we're looking for, which is y and x. Now remember the formulas for x and y. They are x equals r cosine theta, and then y equals r sine theta. So for the x value, we will use 7 and then multiply that by cosine 30 degrees. Cosine 30 degrees turns out to be 0.86 and some change, but multiply that by 7 to get your answer rounded to the 10th place of 6.1. And then we need to find the y value, so we'll go y equals 7 times sine of 30 degrees. Sine of 30 degrees, and then multiply by 7, that comes out to be 3.5. Therefore, your final answer for this is going to be 6.1 and then 3.5. Before we finish with the problem, let's take note of the fact that we have a 30, 60, 90 triangle here. And if you'll remember, this is going to be the short leg, this is the long leg, and this is the hypotenuse. Alright, so the short leg is half the hypotenuse. Did our answer come out to be half of the hypotenuse for y? Yes, it's 3.5. And then to go from the short leg of 3.5 to the long leg, you could multiply 3.5 by the square root of 3, and you would still come out with the same value. But we still have a final answer of 6.1 and 3.5.